what we did, I guess it was last week. Seems like forever now. With the division, the long division of polynomials, because today I'm going to give you a shortcut, simplistic way of doing things, and then we're going to continue on with factoring. So we're going to go a little faster than we have been all semester, because a lot of the stuff is not changing, and we're just manipulating things a little bit differently. So first off, when we convert this into long division, is there anything that might be required of us that's a little bit different? In other words, my divisor is x minus 2, and I'm going to need a 0 for which term?
It will be x to the first.
X to the first term. So we have to write this as 2x cubed minus x squared plus 0x minus 7. It's kind of like a place value system. If you have a missing term, you have to replace it with 0. All right, and then you start your long division, and you concentrate on the first terms of the two polynomials. In other words, what times x will give you 2x cubed?
2x.
2x squared. So if you put 2x squared here and you distribute it down, you're going to get 2x cubed minus 4x squared. What do we do with that term? Expression. Stare at it. Okay. Subtract it.
Bring down the x.
So we're going to take this and subtract it, which means we're going to go inside and change the signs. So instead of this being a positive 2, this becomes a negative 2. Instead of this being a negative 4x, it becomes a positive 4x. Okay. And then you just add down. So the 2x cubes will cancel. Negative x squared plus 4x squared is
3x.
3x squared. And then drop down your 0x as your placeholder. Okay. And then, what times that x way up front is going to give us 3x squared?
3.
A positive 3x. And if we distribute it down, we're going to get our 3x squared and a negative 6x. And we're going to take that expression and subtract it, and or change all the signs. So the subtraction becomes addition, the 3x becomes a negative 3x, the negative 6 becomes a positive 6. And then add, the 3x squares cancel, and we're left with 6x minus 7. So far so good? All right. What times x gives us 6x?
6.
A positive 6. Make sure you say positive or negative. That way you have an operation to work with. 6 times x is 6x. 6 times negative 2 is negative 12. And then you're going to take this expression and subtract it. So if we subtract it, change all the signs. And we end up with a remainder of 5. Now, when we write our answer, it's going to be the quotient, which is 2x cubed, 2x squared, I'm sorry, plus 3x, plus 6. And then we have to add on the remainder part. Remember, it's the remainder over the divisor. So it'd be plus 5 divided by the quotient x minus 2. Not the quotient, the divisor. And there's our answer. Now, for this type of long division, the ones that lead off with a x, like x minus 2 or x plus 5, you're dividing by it, there is a shortcut. And that shortcut comes from a recognition of something. Notice the 2x cubes here are canceling, the 3x squares are canceling, the 6x's are canceling. There's a lot of extra writing in this problem. So another way of looking at this is to get rid of all the unnecessary stuff. For instance, this x really isn't doing anything. All it's doing is getting rid of the x cubes, the x squares, and the 6x at the bottom here. So the only thing really giving us answers is the negative 2 part of that polynomial. So there's a way of, well, condensing it, and that's what we want to talk about today. So this would be 5/3. And it's called synthetic division. And synthetic division is actually basically a placeholder system, or a place value system. We're going to convert polynomials into a place value system. For instance, if I write this on the board, 3 times 10 to the 4th plus 2 times 10 to the 2nd plus 7 times 10 plus 4. What number am I really talking about?
3,274.
3,274?
No, 30,000.
30,000, because it's 10 to the 4th. So it would be 30,274. And like I was discussing last time, polynomials somewhat behave like our place value system. And what we're going to do is we're going to force the polynomial to actually behave like our place value system. So for instance, if I give you 7x to the 5th minus 3x cubed plus 4x squared minus 7x plus 5 is my polynomial, big, ugly, long, nasty thing, we're going to convert it into a place value system. And what we're going to do is exactly what we did up here. We take the 3, write it down, take the 2, write it down, the 7, and the 4, and if something is missing, we replace it with a 0. Uh-huh.
I'm sorry, I failed this time. I'm trying to come to your place.
You what?
I failed.
Hope you're okay. So we're going to write this as 7. Just suck off that coefficient. What do I write next though? That's important.
0.
0, because we have a missing power. The 4th power is missing. So I'm going to write 0. Don't put them next to each other like a regular number, because these numbers could be positive and or negative, or they could be 2 digits, 3 digits, so you have to kind of give it a little bit of space. So we have 7, 0, x to the 4th. The next number down would be negative 3. The sign has to come with it. The next number down would be 4. The next number down would be negative 7. And then finally, 5. So this is kind of like a placeholder system for a polynomial. And you can kind of think of it as the 5 is x to the 0, the negative 7 is x, the 4 is x squared, the negative 3 is x cubed, the 0 is x to the 4th, and 7 is x to the 5th. So it has a place value to it, multiplying up by factors of x. Okay. So how does that help us? Well, if I take that original problem over there, the 2x cubed minus x squared minus 7, and we're going to divide that by x minus 2. X minus 2, yeah. X minus 2. And I convert the first polynomial, the divisor, dividend, as a place-holding system. It's going to be 2.
0.
Nope.
No, x.
Nope. What kind of 1? Negative 1. The coefficient of x squared. Coefficient of x squared. Next number? No.
No, 0.
0, because we don't have an x. And then finally, negative 7. If you come back over here, that's exactly what we have. Here's 2, here's negative 1, here's 0, here's negative 7. So the two things, correspond. You're taking the coefficients to represent the place value. All right, second thing that synthetic division does. Notice one thing that we did all the way down through this problem. We changed all of these subtractions into additions, and then multiply through by the negative. So instead of multiplying through by a negative to create subtraction, I could have just changed this sign. Instead of x minus 2, I could have made it x plus 2. So the way we set it up in synthetic division is we don't care about the x, because the x really isn't doing anything. It's just getting rid of those 2, and those 2. So it's just removing common like terms. So instead of putting a negative 2, I'm going to put a positive 2. Now synthetic division takes long division and actually flips it upside down. Instead of the answering showing up at the top, it's going to show up at the bottom. And this is how it works. The first number that came down in our answer was this 2 here. And it's going to be 2 no matter what that first number is. So the first step is, this is part of my answer one way or the other. It's going to be a 2. All right, what happened with this 2 when I multiplied it by this 2? Well, it gave me the 4. So I'm going to take this 2, multiply this 2, and get 4. I'm just going to write it there. What happened to the 4? Well, the 4, and I subtracted 1. So what should I do with these two numbers? Add them. Just add them. Yeah, because look over here. It's negative x squared plus 4x squared is 3x squared. So I'm going to write this down as 3. Just add them together. All right, what number came up next? The 6. So 2 times 3 is 6. And what did the 6 do? Well, it added to the 0 there. So 0 plus 6 is 6. And then 2 times 6 is 12. And 12 minus 7 is 5. And it has a remainder of 5. So it does the exact same thing as long division, except without all the x's. None of the x's, actually, which is kind of nice. But now we're back into our place value system. So what does this represent? Well, this is the remainder, so this isn't part of the polynomial. This represents 6. This represents 3x, and this represents 2x squared. See, this has a power of 0. This has a power of x, 1. And this has a power of 2, just like a regular old place value system. The 1s, the 10s, the 100s. So this is 2x squared plus 3x plus 6 plus that remainder 5 divided by the original quotient, which was x minus 2. Gives you the exact same answer, but with a lot less work, which is kind of nice. So that's what we're going to do a little bit of today. Most people get this pretty quickly. The only hard part is the missing powers sometimes. Other than that, as long as you keep your operations straight, pretty safe. So let's try this one. This is number 15. Page. Ooh. Page 258. Stealing a problem from the previous section. X cubed minus x squared plus 11x minus 1 divided by x plus 1. So when we're changing this into synthetic division, your first step is going to be convert the dividend into place value type system. So it starts off with 1. Next one. Negative 1. Next one. 11. Next one. Negative 1. Just make sure none of the powers are missing, because if there's a power missing, you do have to replace it with a 0. All right, and then you put your divisor out here. What am I dividing by? 1. Negative 1. You're going to go opposite sign to take care of all that subtraction. And you're going to draw a line. That's like the top of the long division sign. And do synthetic division. First step. Take that first lead coefficient and drop it. It's part of our answer one way or the other. So you drop a 1. And then it's always multiplication on the diagonal and addition on the vertical. So negative 1 times 1 is negative 1. Negative 1 plus negative 1. Negative 2. Negative 1 times negative 2. Positive 2. 11 plus 2 is 13. Negative 1 times positive 13. Negative 13 minus 1. Negative 14. And that last number is always going to be a remainder. So our answer is this. That's our remainder. You can ignore it. This is the one without an x. This is the one with an x. This is the one with x squared. X squared. So the answer is x squared minus 2x plus 13 minus 14 divided by what? Not negative 1. This represents something which is x plus 1. And there's our answer. It's a neat little trick. It does have its drawbacks, though. Let's make up one. Yeah, that should work fine. Keep the numbers nice for a little bit. Okay. So what's the first thing we write down?
4.
4. What's that? 0. Because we don't have an x to the 4th. -3. +2. And a -5. Really?
We have 0.
That's another 0. We have a term that's missing, it's x. So we got to put a 0 in here, and then finally, -5. I can't even talk today. I highly suggest that you figure out what is really going on here. For instance, this one over here, the degree of the polynomial is 3. How many numbers did I write down for the synthetic division? 4. The degree of this polynomial is 5, so I better have 6 numbers written down. So if you have the exact same number or less, then you're missing a 0 someplace along the way. All right, what am I synthetically dividing by? A +1. And sometimes these numbers can get kind of big because something underlying all this mess that you'll learn in college algebra. Drop the 4. 1 times 4. 4. 0 plus 4. That's easy. 1 times 4 is 4. 4 minus 3. 1. 1 times 1 is? 1 plus 2 is? 3. 1 times 3 is? 3 plus 0 is? 3. And then 1 times 3 is? And 3 minus 5 is? -2. Where do most people make their mistakes here? Well, the operations will get you because there's a lot of signs, so more than likely sign mistakes. Adding when you're supposed to multiply, multiplying when you're supposed to add. Those are the common mistakes. Forgetting the zeros is probably one of the bigger mistakes. But signs are the ones that will drag you down. If you got an answer wrong, like in the lab tomorrow, more than likely you just changed the sign when you really shouldn't have, or added incorrectly. So it's just little errors that will pop up every once in a while. What's our final answer here, though? Well, the clue is ignore the remainder, count up what's left. 1, 2, 3, 4, 5. So the degree has to be 4. It's always going to be 1 less. So this is 4x to the 4th plus 4x cubed plus x squared plus 3x plus 3 minus
2 over x.
over x minus 1. So synthetic division is actually kind of a quick way of getting to an answer. So when does it not work? Well, when you're divided by something that doesn't have just plain old x, like 2x plus 1. See what happens. I highly suggest if it does turn out to be 2x plus 1 as your divisor, or 3x minus 2, or something strange where the lead coefficient is at 1, I suggest that you do it by long division. Go back to writing it all out. And I'll show you why. If we take a simple polynomial, 4x squared minus 6x plus 5 divided by 2x plus 1. No idea what this is going to do, but it's going to be messy. If we're going to synthetically divide this, you have to force this bottom 2x to become 1x. What is one way of doing that? Divided by 2. Now, If I divide this 2x by 2, what else do I have to divide by 2? Everything, including the top and this 1 over here and the 5. It's going to get a little messy. So if we divide everything by 2, 4x squared divided by 2 is 2x squared. Negative 6x, let me put this big divided by 2. Negative 6x becomes negative 3x. Positive 5 becomes 5 over 2. And you're going to divide by 2x divided by 2 is x, and 1 divided by 2 is a half. So it creates fractions, and sometimes these fractions can get a little ugly because then you have to multiply fractions and you have to add fractions, and it just gets messy, and it's actually easier to do it long division, but this one's not horrible. So what does my place value system look like? 2, negative 3,
and then plus
5 halves. You don't have to write pluses, just the minuses are the only ones that are really important. And what am I synthetically dividing by? Negative 1 half. So I have to multiply things by a half, which can get a little ugly. So drop the 2. Negative 1 half times 2. Careful. Negative 1. Signs are extremely important. Negative 3 minus 1. Negative 4. Hey, that's nice. Negative 1 half times negative 4 is 2. So we write that here. 2 plus 5 halves.
Oh, plus.
Yeah, you're adding here. Because it's a negative times a negative is a positive. 5 halves plus 2 is the same thing as 5 halves plus 4 halves, which is 9 halves. You guys in fractions. Common denominator. 2 is the same thing as 4 halves. All right, so my answer is 2x minus 4 plus 9 halves over x plus a half. Now, if you get down here, obviously that's not very, well, nice looking. So one thing you can do here is, kind of like at the beginning, we divided everything by 2. In this last fraction, what can I do? Multiply everything by 2. So it's better to write it as not the 2x minus 4. Leave those 2 alone. Just this fraction. So if you multiply the top by 2, you just get plain old 9. If you multiply the bottom by 2, both of them, what do you get? 2x plus 1. You're back to your original divisor, and there's your answer. If you did this by long division, you would get the exact same answer. It's just sometimes synthetic is a little bit quicker, but sometimes the fractions can be overbearing. So that's it about synthetic division. It's not super important, but it's kind of cool. All right. Next little thing. Where to start? This is 5, 4. We're going to start talking about factoring. Division is actually part of factoring. Remember I showed you that if you have a remainder of 0 that you've actually taken the polynomial and factored it into 2 pieces. GCF is another type of factoring, which is kind of nice, and I want to show you basically what goes on in your head when you're doing these types of problems. So for instance, real simple one. 7a squared minus 14a. Nice little binomial. The way we're going to tackle these is pieces. You're going to take care of the numbers, and then you're going to take care of the variables, the letter part of it. And the way factoring works is it's actually the distribution property backwards. We're just going to undo the distribution. So what do the numbers have in common? 7. They are both divisible by 7. So you try to pull out the largest number possible. And if you don't, later on you could probably find it and pull it out at the end. But you always want to try to pull out the biggest possible number. So we're going to yank out a 7. What else can I yank out? The A. Now, technically, when you're yanking the 7a out, you're leaving the pieces behind by division. Because when you multiply it back through, you want to come back to this answer. So the way I usually show it is, you're taking the original polynomial and you're dividing away what you're pulling out. So this is what you would do inside your head. You normally wouldn't write this on a piece of paper, but I like showing it because sometimes when you get stuck, you go back to this and it unsticks you. So what do I divide by? Well, you divide by what you yank out. Why does this work? Well, if I distribute the 7a, what happens to the two 7a's on the inside? They cancel and you're back to the beginning, which is where you want to be. So on the outside is this 7a. What's 7a squared divided by 7a? Just plain old a. Minus, what's 14a divided by 7a? 2. So this greatest common factor is 7a, and when you pull it out, it leaves behind a minus 2. One of the main reasons I like doing it that way is if you have something like this. Actually, oh, wait a minute. That's not what I wanted. Something simple like this. If we look at the numbers, what's the greatest common factor? 12. The letters? X cubed. It'll always be the lowest power of the variable. So you're always looking for the smallest one because that's the one you can yank out of all of them. So we're going to pull out x cubed. And the reason I like this method is, well, people are funny. If you choose, some people, they do this in the head, they'll say, well, the 4x, 48x to the 4th divided by 12x cubed, it'll give you some answer here. And then they'll look at this and say 12x cubed divided by 12x cubed is 0. And they'll write one term on the inside instead of the two that are proper. So if you get it stuck in your head that you have to have two answers, you'll never make a mistake with this last term. And it's a weird mistake when people make it. So you're going to divide by what you yank out, which is the 12x cubed. And then whatever's left behind is your answer. So on the outside is this 12x cubed. On the inside, 48 divided by 12 is 4. X to the 4th divided by x cubed, x, minus 1. Factoring never ever leaves behind a 0. It'll either leave a 1 behind or some other kind of factors. All right, how much harder can we make this? Let's try. Ooh, that one's horrid. This is number 10. This is page 268. Negative 12x squared y minus 18xy plus 6x. Trinode it. Now here, instead of looking at just two terms, you have to look at every term. Doesn't matter how many terms you're dealing with. If you're pulling out the greatest common factor, you have to look at them all. So what number divides evenly into 12, 18, and 6?
6.
Just the 6. So we're going to yank out the 6. What power can we take out of the x's if there's an x squared, an x, and an x?
X.
Just plain old x. What about y?
No.
You can't touch it because it's in the first two, but it's not in the last one. It has to be common between all of them. All right, and then leave behind with division. I'm not going to write the division down, but at least do it in your head. Negative 12 divided by 6. Careful, it's negative 2. X squared divided by x is x. Y is going to be divided by 1, so you're just left behind with y, because there is no y being pulled out. Negative 18 divided by 6.
Negative 2y.
Negative 3. The x goes away, because x divided by x is 1. And then the y just kind of drops down. Positive 6 divided by positive 6. Well, actually, positive 6x divided by positive 6x.
1.
Leaves you with a positive 1. I highly suggest after you pull these common factors out to go through and make sure that there are none left behind, because sometimes the numbers get kind of big and you might pull out 2 when you really should have pulled out 6. It would leave behind a factor of 3 that you can yank out later if you wish. That just means you didn't pull out the biggest one possible. Not that bad, right? Pretty easy. Of course, they can get uglier. Number 16. Oh, 4y, x minus 5y, minus 3 times negative 5y plus x. I don't know why they wrote it that way, but they did. It's really important before you start these type of problems to figure out how many terms are you dealing with. So as you look at this problem, how many terms are we dealing with? 4. Why do people say 4? What separates terms? Addition and subtraction. So these two are multiplied together. That can't be more than just one term. And these two are multiplied together, so this must be another term. This actually only has 2 terms. You can't go looking inside parentheses for terms. They have to be separated. They have to be separated. So technically, there's only 2 terms here. Here's the first term, and the negative 3 times the negative 5y plus x is the second term. Remember, when you group things in parentheses, they're just a single, number, variable, if you want to think of it that way. So out of these 2 terms, do they have anything in common that I can pull out? Really? This is 4y times x minus 5y. And this is negative 3 times negative 5y plus x.
I took it out
Aren't x minus 5y the same as negative 5y plus x? What property did they use here?
Commutative.
Commutative property. So
Got one right.
x minus 5y is the same thing as minus 5y plus x. I can take out this common factor, and I can write it the way I want to, which is x minus 5y. So kick out x minus 5y. Then you figure out what's left behind, but you do it with division. So 4y times x minus 5y divided by x minus 5y is,
4y.
well, 4y. This one is just commutative, so when I divide it by x minus 5y, it becomes 1, and you're left with negative 3. And there you are. That's as factored as it's going to get. Oh, jumping ahead to answers isn't helping me. I'm not going to get into the super ugly ones, so we'll avoid that. How about something like this? 3x, 2x minus y minus 4y minus 2x. Now, with number 16 here, it literally was the commutative property. You just took the sum and you reversed the order of it. Is this the commutative property when we write 2x minus y and y minus 2x?
No.
No, because subtraction is not commutative. So what happens when you commute over subtraction? What happens when you commute over subtraction?
Oh,
It's simple enough to test. And if you do 5 minus 2, the answer is 3, I hope. And if you do 2 minus 5, the answer is negative 3. So when you commute over subtraction, you actually multiply it by a negative. You're changing its sign. So I can fix this one, or the other one, doesn't matter, but I like putting the x's first. I can fix that one by flipping it, commuting it over subtraction. Well, what do I have to do to it? So instead of having a negative 4, we're going to have a positive 4. So this becomes 3x times 2x minus y plus 4 times 2x minus y. So if the order under subtraction is backwards, you have to fix it by changing its sign, flipping it and changing its sign. What can I pull out now?
2x minus y.
2x minus y. And if I yank 2x minus y out of these two terms, what's left behind? 3x plus 4. We get a nice little factored out expression. So that's a neat little trick to know that if you commute over subtraction, you do have to change the sign.
What about sign that I change it? What'd you say?
If you commute over subtraction, you have to change the sign in front of it. So if you have something like 4 minus 5x, and you want to write it as 5x minus 4, to keep it equal, you have to take this thing and multiply it by a negative. Because look what happens. Negative 1 times 5x is negative 5x. And negative 1 times negative 4 is positive 4. So it keeps the equality. That's what's important. You don't want to change things. You want to keep the equality. All right. There's an extra step to this now. Don't want to do those. How about, which one? Yeah, 26. Nice simple one. X cubed plus 8x squared plus 2x plus 16. Now this is still in the greatest common factoring setup, but it's not a perfect one. Because if you look at it, do all terms have an x?
No.
No. Is there any greatest common factor between 1, 8, 2, and 16? Well, yeah, it's 1, but that's kind of trivial. So this isn't going to work like the original one, so we're going to change it a little bit. And this only works if the number of terms, how many terms are up here? 4. It only works if it's an even number of terms. And the way we're going to do it, this one's called grouping. We're going to group terms together and see if that helps us get through the problem. Do not use parentheses to group. The symbol I use is a little arrow. You're going to take the first two terms and you're going to pull out the greatest common factor just for the first two terms. So what's the greatest common factor between x cubed and 8x squared?
X squared.
X squared. You're going to kick it out. What's left behind, now you could use your parentheses because you use the distributive property. You're going to be leaving behind x plus 8. And then you're going to group the second two terms and pull out the greatest common factor. Now be careful here. Since we have this as our first term, this one's going to give us a second term. It has to have an operation here. It's either a positive something or other or a negative something or other. In this case, between 2x and positive 16, what are we going to pull out?
2.
You have to say positive 2. It needs an operation. So you're going to go positive 2. What's left behind? X plus 8. This plus sign is the most missed sign in this type of factoring. People just drop it off because they're not used to writing positive 2. They just write 2. All right, and now we're down to two terms. Do they have anything in common?
X plus 8.
When this thing works, these two will always be exactly the same. So you yank out x plus 8, what's left behind?
X squared plus 2.
You get rid of it, you're left with x squared plus 2. It's a neat type of factoring. Does it always work the first try? Well, no. But there is a neat trick to fix it. See if I can find one that doesn't work on the first try. Maybe. Yeah. This is 36. 25x squared z minus 14y minus 10yz plus 35x squared. Again, 4 terms. So this grouping technique should work, where you concentrate on the first two and the last two. So the first two terms, the 25 and the negative 14. What is the greatest common factor between 25 and 14? 1. Kind of boring. What's the greatest common factor between x squared z and y? 1. It's trivial. So some people will be like, oh, this doesn't work. But it might. There might be just a little trick. And the trick is this. commute the two middle terms. Just switch their places and rewrite the problem. And this usually fixes any problems that you had in the first step. So 25 x squared z. We're going to move the negative 10yz into this position. What property allows me to do this? Commuted it. Negative 14y into this position, plus 35x squared at the end. And then retry the grouping technique. Group the first two terms. Do they have anything in common now?
5z.
Yeah. 25 and 10 have a factor of 5. X isn't there, y isn't there, but there is a z. Now when I yank out the 5z, remember you have to use division to leave things behind. 25 divided by 5 is 5. The z's are going to cancel and you're left with x squared. The next one's going to be negative because negative divided by positive is negative. 10 divided by 5 is 2. Y stays behind, but z is divided by z is just 1, so that's gone. So the first term becomes 5z, 5x squared minus 2y. And then concentrate on the next two. Now this is important. With this problem up here, we factored out a positive 2. Take a guess what we're going to factor out here. Negative whatever the number is. The sign becomes the operation that you want. So we're going to yank out a negative 7. Is that it? Oh, darn it. What's left behind? Well, negative 14 divided by negative 7 is 2. The y stays behind. Positive 35 divided by negative 7 is negative 5. And leave behind the x squared. That's why I like the division. It gets the signs correct too. So it's probably best to go through, especially that second number, and do the division. Are there any like terms in our two terms that we've come down to? They're pretty close. I mean, they both have a 5x squared and they both have a 2y, but the order's backwards. So how do I fix that? Change the sign. So I'm going to yank out 5x squared minus 2y. But when I leave things behind, I'm going to realize that I'm commuting this problem, and that negative 7 really becomes a positive 7. So the final answer is 5z plus 7 instead of negative 7. Because we're doing that little commuting over subtraction. So that one had a lot of the neat little tricks involved in factoring. Sometimes the order's wrong, you got to fix it. And if you do fix it, you want to make sure you keep it equal. That's really important. You don't want to be changing signs just because it fits your needs. And the other thing is, when you factor out a negative, make sure you change the signs of everything you leave behind. A lot of people were saying that that was positive 5 instead of negative 5. And you usually will catch yourself because over here it's 5x minus 2y, and this one would have been 2y plus 5x squared, and it just wouldn't match up. And that's usually an indication of a mistake. Now, by themselves, GCF factoring should be used first. If I tell you to factor a polynomial, the first thing you should do is look for a GCF and pull it out. What that does is it makes the numbers, well, smaller. And that's really